Hello students, welcome back. Today we will start with exercise 11.2 of chapter number 11, that is conic section. Before starting exercise 11.2, let's see about parabola. In this exercise we will solve the sums related to parabola. So first let's see what is a parabola. Or what type of curve is a parabola. This is the curve of parabola. Now see here, if we consider this S, that is the foci, its coordinate will be A0, vertex 0, 0. We'll consider this as a vertex. And there will be a line such this. This is the directrix. Okay. Now say in parabola, if I take here, let's take this point as B, or let's take this M. Okay, now if I take any point on this curve, then the distance SP and PM both will be same in this type of curve. Here, let me just make the figure clear. Now see, here you can see that in every case or any point on the curve, the ratio SP upon PM, that is called the eccentricity, that will be equal to 1. Okay, the ratio SP upon PM, that is the eccentricity, and that is equal to 1. If this ratio is less than 1, then it will be ellipse. If it is greater than 1, then it will be hyperbola. So at present, let's see about parabola only. So in every case, the ratio SP upon PM, where what is M? M is the foot of perpendicular from any point of the curve to the directrix. Clear? So now, see, there are different parts that we will see. First, we will see foci or focus. For any parabola, the focus will be A0. Okay, the focus will be A0. The vertex that will be equal to A0, 0. The directrix, the equation of directrix. Here the directrix is a line such that on any point of the curve, if we take the ratio SP upon PM, that will be equal to 1. So here the directrix will be equal to x equal to minus A. Okay, this is minus A, means this point will be equal to minus A 0. And the equation of parabola, the equation of parabola will be equal to y square is equal to 4ax. So if this is the equation of parabola, then the foci will be a0, vertex 0, 0, directrix x equal to minus a. Clear? Now, take if I take any 2 points on the parabola such that if I draw a chord or line passing, and if the line passing through this foci, okay, then this PP dash, that is called the focal chord. Okay, what is this? Focal chord. Okay, and if that focal chord is perpendicular to the axis, see in this case this is x-axis, this is y-axis. So here axis of parabola, axis of parabola, that is x-axis. Okay, so if I draw a focal chord, which is perpendicular to the axis of parabola, then that is called latus rectum. Okay, that is called latus rectum. So the coordinates of latus rectum, see, this is a0, so definitely at this point the x coordinate will be a, and at this point also the x coordinate will be a. Clear? Now, if I put this in equation, y square equal to 4ax, x will be equal to a, so 4a square, right? Y square will be equal to 4a square. So y will be equal to square root of this, that is plus minus 2a. So here it will be plus 2a, and in below it will be minus 2a. Okay, so these are the coordinates of lattice rectangle. Clear? So let's name this point as C and C dash. Coordinates of lattice rectangle, that will be equal to A plus minus 2A. Clear? And the length of lattice rectangle, length of lattice rectangle. See, from center point to this point, the y coordinate is 2a, and even in below it is 2a. So 2a plus 2a, 4a. So I will write it down modulus of 4a. Modulus of 4a because distance cannot be negative. Okay. So length of lattice rectangle will be equal to 4a. These are the characteristics of parabola. So just note it down. Remember, equation of parabola y square equal to 4x. See, it cannot be on one side only. It can be on other side also. But for this parabola, the equation of is y square equal to 4ax. Okay. So the foci will be a0, vertex 0, 0, equation of directrix minus x equal to minus a, axis of parabola. Okay, that will be the x-axis. Lattice rectum a plus minus 2a, and length of lattice rectum 4a, more or less of 4a. So first, just note this down. Now see, these are the different types of parabola. The first case, okay, which we have already done earlier. In this case, the equation will be y square equal to 4ax, and which is the major axis? X-axis. So in this case, foci will be a0, vertex 0, 0, x equal to minus a, that is directrix, coordinates of lattice rectum a plus minus 2a, and length of lattice rectum modulus of 4a. This we already discussed. Now in this case, okay, means the parabola, it's in the second and third quadrant. Here again the axis, main axis is x-axis. The equation will be y square equal to minus 4ax. Or else I can consider 4ax. Or else I can also write down y square equal to 4ax, but the value of a will be less than 0. Okay, so if I consider a as positive, then it will be minus 4ax. Okay, so considering the same equation, here the foci will be minus a0. Okay, you can see here minus a. And directrix x equal to plus a. Vertex in every case it will be 0, 0. Length of lattice rectum, now it's minus a, sorry, coordinates. Okay, because this will be minus a and plus minus 2a. And length of lattice rectum, again modulus of 4a. Clear? Now, if the major axis is y-axis, okay, then in that case, the general equation of parabola will be x square equal to 4by. Even in this case also x square equal to 4by or minus 4by. Okay, where we will be negative, so it's minus 4by. So in first case, it's 0b, that is the word foci. In second case, as it is in negative y-axis, it's 0 minus b. Vertex, both case 0, 0. In first case, the directrix will be this, that will be y equal to minus b. In this case, equal to y equal to plus b. The coordinates of lattice rectum, now here y coordinate will be b and x coordinate plus minus 2b. And in this case, y coordinate minus v, x coordinate plus minus 2b. Modulus, sorry, length of lattice rectum, in both the case, it will be modulus of 4b. Clear? So these are various different types of parabolas in various region. So note down this chart. Now let's start with the exercise. Exercise 11.2. In each of the following exercise 1 to 6, find the coordinates of the focus, axis of the parabola, the equation of directrix, and length of lattice rectum. Okay, so I will solve 2 or 3 and rest you have to solve it by yourself. So let's take the first one. Y square equal to 12x. Now as it is y square, the major axis is The axis is x-axis. So comparing it with y square equal to 4ax, we get 4a is equal to 12. That means a will be equal to 3, right? So foci a0, that is 3, 0. Their equation of directrix, okay, equation of directrix, that will be equal to x equal to minus 3. Okay, remember, if you are taking here 3, here will be minus 3 in equation of directrix. Okay, length of latus rectum, length of latus rectum, that will be equal to modulus of 4a, that will be equal to 4 into 3, and that is equal to 12. So the length of latus rectum is 12. Okay, now I am solving the third one. Y square equal to minus 8x. So now again it is y square. So again the axis is x-axis. Comparing with y square equal to 4ax, I will get 4a equal to minus 8. So a will be equal to minus 2. So now the foci, that is minus 2, 0. Okay. Equation of directrix, x equal to minus of minus 2, that is plus 2. Length of latus rectum, modulus of 4a, that is the modulus of 4 into minus 2, that is minus 8, and that will be equal to 8. Clear? This was about the third question. Okay, now I will solve one more, that is, let's solve it. Question number 4. Question number 4, that is x square equal to minus 16y. Now say, as it is x square, the axis is y-axis. Clear? Now comparing it with x square equal to 4by, I will get 4b equal to minus 16. That implies b is equal to 4, minus 4, sorry. It's minus 4. Foci. Now as it is y-axis, the foci will be 0b. So 0 minus 4. Equation of directrix. Now as the axis is y-axis, it will be y equal to minus b. So minus of minus 4 plus 4. And length of latus rectum, modulus of 4b, modulus of 4 into minus 4, modulus of minus 16. So that will be equal to 16. Clear? So this was about the fourth one. So question number 2, 5 and 6, you solve it by yourself. Okay. At present, note down question 1, 3 and 4. And based on this method, solve question 2, 5 and 6. Question 7 to 12. In each of the exercise 7 to 12, find the equation of the parabola that satisfy the given condition. So from 7 to 12, you have to find out the equation of parabola. Let's see the seventh one first. Focus 6, 0. Okay, and directrix x equal to minus 6. So comparing with focus A0, A is equal to 6. The equation y, general equation is y square is equal to 4ax. So y square equal to 4 into 6 into x. That implies y square is equal to 24x. Okay, so this is the general equation of parabola for question number 7. 8. Here the focus is given 0 minus 3. and the directrix y equal to 3. Now see, if the directrix given is y equal to 3, that means that the major axis will be y axis. So comparing with focus 0b, I will get b equal to minus 3. And as the major axis is y axis, the general equation will be not y square, x square equal to 4by. That means x square equal to 4 into minus 3y. So that implies x square equal to minus 12y. Okay, so this is the equation of parabola for question number 8. Let's see the ninth one. Vertex 0 0, focus 3 0. See, here y component is 0 in focus, so comparing with a0 we will get a equal to 3. So the general equation y square equal to 4ax implies y square equal to 4 into a 3 12. So y square is equal to 12x. So this is the general equation of parabola for question number 9. Question number 10. Here the vertex is given as 0 0 and focus minus 2 0. So again comparing with the focus of parabola a0, because y component is 0, we get a equal to minus 2. So the general form y square equal to 4ax, that will give y square equal to 4 into minus 2, that is minus 8x. This is the general equation of parabola for question number 10. So this was about question 7 to 10. So just note it down. Now let's see the next question, that is 11th. Question number 11. Vertex given is 0 0. Passing through point 2 3 is on parabola, and major axis, the parabola is along x axis. Now as it is along x axis, the general equation will be y square equal to 4ax. Okay, now see, point 2 3 lies on this parabola. So let's put down the x and y coordinate. 3 square equal to 4a into 2. Clear? So 3 square 9 is equal to 8a. Okay, so a will be equal to 9 by 8. I got the value of a. So now let's put in the general equation, that is y square equal to 4. Instead of a, I will write down 9 by 8 x. 1s are 2s are. So y square equal to 9 by 2x, or 2y square equal to 9x. This is the general equation. Sorry, this is the equation of parabola whose vertex is 0 0 and 2 3 is a point on the parabola. Okay. Now let's see the next and last for this exercise, that is 12. In this question, the vertex is 0 0, point is phi 2. Now it is symmetric with respect to y-axis, means the parabola is along y-axis. So the general equation of parabola, it will be x square equal to 4by. Now this point is on the parabola. So let's put down this phi square equal to 4 into b instead of y 2. So 10 is equal, sorry, not 10, phi square, it's not phi 2. So 25 equal to 8b. So what does that mean? B is equal to 25 by 8. Now putting this value of b in general equation, x square equal to 4 into 25 by 8y. 4 ones are 4 twos are. So either x square is equal to 25 by 2y or x 2x square equal to 25y. Okay, so this is a general equation. Sorry, this is the equation of parabola with vertex 0, 0 and point 0.52. So this was about question number 11 and 12. Just note it down.